Alrighty, welcome to lesson 4, this one on rational exponents. So all those exponent laws we looked at before will stay the same. The only change here is now you might see exponents that aren't necessarily, integers or whole numbers. They are going to be rational numbers, which encompasses all of the fractions, which you learned about in grades 7 and 8. So we do need to remember the rules of dealing with fractions. So just a little bit of review. If we're going to add or subtract some fractions, the one thing we need is a common denominator. Now, most people start learning about fractions in terms of a pizza. Now, you can only really say that you're adding slices together if the slices are the same size, right? It doesn't make sense if you had 2 slices and your friend had 3 slices, but if their slice is the size of half of a large pizza and your slice is the size of a quarter of a large pizza, you haven't really eaten the same amount of pizza. So we need to make sure that the size of the slices are the same. We need to make sure that the denominators of these fractions are the same before we can add them, before we can combine. So we'll start by looking at a couple. So for A here, if I look, I've got 2 out of 5, 2/5 plus 4/5. Okay, the size of those slices are the same, so we can combine and say that in total we have 6 pieces of pizza that have a size of 1/5. So we have 6/5 in total. So keep that analogy going through the same thing. I find that it usually helps students. For B, we have 2/3 and we're adding 1 whole. Now, those don't have the same common denominator right now. We need to change this 1 so it's got a common or a denominator of 3. Right now, it actually has a denominator of 1. And the way that you learned to do this before is multiply both the bottom and the top by a number to change it. And if it's a fraction, you have to do the same thing top and bottom. So this one will become 2/3 plus 3/3, right? 3 pieces of pizza, if they each have a size of 1/3, that is the entire pizza. Okay, so that's 5/3 in total. For C, there's a couple ways you could approach it. We can choose to change that denominator of 7 into a denominator of 21, or we could divide both the top and bottom of the second fraction by 3 to change it to a denominator of 7. Both totally work. I do have to make sure that I fully reduce my answer. So I'm going to choose to divide the second fraction by 3. This will save my reducing that I don't have to do at the end. So we're going to have 2/7, and we are going to be adding to it 1/7 for a total of 3/7. Now this fraction is already in lowest terms. I don't have to worry about that because I took care of it in the first step. Okay, if we're going to multiply or divide, the rules are a little different. Adding or subtracting is actually the difficult one because I need that common denominator. For multiplication and division, you don't, which is really, really nice. And again, we'll fully simplify. When we go to multiply, I know we've talked about multiplying fractions before, but when you looked at it before in just terms of numbers, you went numerator, multiply with numerator, denominator, multiply with denominator. The same thing is true. So we end up with 24 over 15. You're going to multiply straight across, okay? And then we're going to reduce this fraction. So find a number you can divide both top and bottom by, and it looks like 3 is going to be our number. So we'll divide both by 3, and we will get 8 over 5. Now, in junior high, you learned about mixed numbers. So you had part of your whole, and then you had whatever fraction was remaining. In high school, those mixed numbers kind of die, and we are going to stick to leaving our answers in improper fractions. That's much better for us. And you'll see when we get to talking about slope and all of our linear equations that this actually makes a lot more sense. Now, what happens if you only really see one fraction? Technically, you can write that 4 as a fraction as well. So just remember it's a denominator of 1, and then you can multiply again just like before. So 3 multiplies with 4 to give us 12, and 2 with 1 to give us 2. Now, usually when you're multiplying by that whole number, this is where you're going to see some reduction in your fraction. You have to make sure you do it to lowest terms. So 12 divided by 2, that is 6. And there is our lowest term simplified answer. Now, division is a little strange. Oops, where did I end up here? Okay, division is a little strange. Now, the rule you learn for division is you take basically the second fraction, you do its reciprocal, and then you multiply. Now, I'm not going to get into all of the reasoning why right now. That'll take up a little bit more time in this video than I want to. But I can link some stuff in the description down below that maybe if you want to read up on it, because you did look at it before, on why the division of fractions turns into a reciprocal and multiply scenario. So here, we can just use that idea, change this to a multiply question, and we're multiplying with 5 over 4 instead of 4 over 5. Now, here I recognize that I've got a 5 in the denominator for the first fraction and a 5 in the numerator. So technically what happens is those 5s cancel out and I'm left with 2 over 4. Now I'll keep the same idea and multiply straight across, but I already know the answer is going to be a half, and we'll reduce to make sure we're right. So straight across gives us 10 on the numerator, 20 in the denominator for my 5 times 4. And of course, yes, that reduces to give us the 1/2. So I really could have at the beginning just canceled those 5s, okay, and be left with 2 over 4. Either way we do it, we get the same answer anyway. So it doesn't really matter which way you're going to approach that. So that's how we deal with fractions again. Now what we're going to do is talk about some of the exponent stuff from last time, just in terms of, you know, those rational number fractions. So maybe what we'll do actually is I've been saying that word a lot, rational number. Maybe what we'll do is define it somewhere. So I'll put it at the top. Sorry for kind of jumping around here. But a rational number is a number, obviously, that can be written as P over Q, where Q is not equal to 0. Okay, and P and Q are integers. I'll talk a little bit more about number sets in our next video, so come back for that one. But an integer, basically a positive, negative number. Okay, now a rational number is that number that can be written as a fraction, so a fraction of 2 integers, P and Q, where the denominator is not 0, because you know, if you try to divide by 0, maybe I can't make that up there. Okay, if you take something and try to divide by 0, that's where you see you get weird errors, right? Like you can't take something, split it into no groups, and not have any groups. Like mathematically, logically, it doesn't make sense. So I can't divide by 0. So I have to make that restriction that the denominator cannot be 0. Now, 0 can exist on the top part of a fraction because I still get, I will not let me out of here. I could still get a value of 0, but 0 is a whole number, okay? So if we keep the idea of, you know, exponents and all the stuff we did in the last video, we can take a look at how to simplify things that might look like this. So I am multiplying, so the little star tells me I do have bases of x, which are the same. So I add my exponents. That exponent rule doesn't change. Let's pick the right blue here. Okay, so my base stays as x, but when I take 2 over 4 and I want to add it to 1 over 4, I need to make sure I have a common denominator, which I do. Okay, it's 4. So I can add the numerators together, and in total, we have 3/4. Okay, I can't reduce that fraction any further. I don't have any negative exponents to deal with. Here I'm done. Okay, so I just had to make sure I added those exponents together. Okay, here's a division. Okay, so remember that I'm not dividing the exponents, I'm dividing the whole power. So remember the rule that happens there. If I'm dividing powers that have the same base, we're actually going to subtract those exponents. So this turns into being y to the power of 5 over 7 minus negative 2 over 7. Okay, the sign there is important. So when I subtract a negative, I'm actually making this more positive. So 5 plus 2 is going to give us 7 over 7, which of course simplifies to just being y. And our calculator is going to be really nice here. So my calculator has an option to make me turn any fraction into a lowest terms fraction. So I'm going to type this in here and we'll see what we get. So 5 divide 7. Now, there's no fraction button from here on out. We're just going to use divide to represent our fraction. So don't look for a fraction button on yours. That would be like a scientific kind of junior high-ish kind of way. So if you just use the divide button, that really does the same thing. Okay, so minus, and then in brackets again, negative. Make sure you use the negative button, not subtraction. Negative 2/7. Close it. Enter. Does give us that 1 exactly like we said. So there it is, y to the power of 1 as our simplified response. Now, of course, they all won't be that simple. Of course, they are going to have a little bit more work involved. Now, I know I did a few in the last video and even with some of my students that I prefer to deal with all the stuff inside the brackets first before dealing with the exponent on the outside. Now, that's a personal preference. You might feel differently and you want to do something with that exponent on the outside first, and that's totally okay. Now, just remember that we might have different steps, but in the end, we should get to the same place. So if we don't, one of us is wrong, but I don't think it's going to be me. So make sure if you're trying it differently, just really double check your algebra there to make sure that we end up in the same place. So I'm going to simplify the inside first, and you'll see why I want to do that. So the numerator stays as 7 to the power of 2/3. The denominator, I'm multiplying together 2 powers of 7. So there's my base, 7 and 7. The exponents are different. They are rational, and they have the same denominator, which is really nice for us. So I can add those exponents together. So this will give us 7 to the power of 6/3. Now, some of you might be saying, well, Mr. Saw, 6/3 is the same thing as 2. Can I just write that? The answer is yes, you can. I'm just adding them together exactly how they look. So if you want to reduce that right now and put a 2 as that exponent, absolutely you can. Okay, so that's going to stay, and we've got our power of 6 on the outside still. I'm still going to work on the inside here, and I'm going to simplify here because now it's a division of powers of 7. So I can subtract those exponents. So this will give us 7 to the power. Now I've got 2/3, and I'm subtracting 6/3. So I'm going to have -4/3. Okay, and that to the power 6. Now I want to deal with that exponent on the outside. So for me, I like to deal with all the inside till it gets down to something very simple, and then deal with the outside stuff. Let's see if my arrow works today. Straight line. But that one works. Okay, so we'll do that up there. And when I take that exponent of 6 on the outside of the brackets and deal with it with the exponent on the inside, we multiply those together. So this actually becomes 7 to the power of -24/3. Now again, your calculator can help here as well. Now if I type that in, my -4/3, and I multiply it by 6, it tells me it's -8. And then that's not exactly what I have, but looking at this, 24 divided by 3 actually gives us 8. I just forgot to put the negative sign in here. So if I actually simplify that, that would give me 7 to the power of -8. So we are in good shape. I just have to remember that I want to leave my answer with positive exponents, not negative. So when we deal with this, this was the case that we talked about in our last video, where I can divide it by 1, take its reciprocal, and represent it as a positive power in the denominator. So 1/7 to the power 8. And there is our final, most simplified positive exponent answer. I'm not really going to try to do that 7 to the power of 8, and I don't really want to write that large number. So we can leave it as 7 to the power of 8, and that's okay. All right. We'll do a couple more here just for the sake of time. And again, I will make sure that the completed solutions are in that description box, so anybody watching this can try some on their own and then see how they did. So I think 3 more we'll take care of. If you want to stick around, by all means. So again, same question, simplify, leave those exponents positive. Okay, so we'll take a look at C here. And it's nice enough that I don't have a set of brackets and exponent on the outside. That's really helpful. So we can take this piece by piece. So we're going to deal with the coefficients first. So the 4 and the 2 that don't necessarily have powers attached. Technically they are 1s, but we don't see them. So we can deal with those first. So 4/2 is going to simplify to 2 for us. A to the power of -2 on top, a squared on the bottom. we're going to subtract those exponents. So the negatives is where you need to be careful. So use your calculator wherever you can. Don't be too proud to put something as small as -2 minus 2 into your calculator. If that helps you get it correct, of course do that. Nobody is sitting there judging you for typing buttons in your calculator. I do it all the time. So we're going to do a to the power of -4. And then our b's, we have 2/3 on top, 1/3 on the bottom. When you subtract, you get b to the power of 1/3. Okay, now we got to make sure we have positive exponents. So the only one that's the issue is this a. So what we can do is leave everything else alone and then create our denominator with a to the power of 4, positive 4. Now we're done. I don't need to worry about this rational exponent right now. In our next lesson, we'll talk about, or maybe 2 lessons from now, we'll talk about radicals and root signs and their relationship with exponents. So for now, this is perfectly okay. Okay. On to, I believe F is the one that comes next. Now again, this looks a little bit worse because I've got that exponent on the outside. It is a rational number, a whole bunch of stuff inside. But again, I am going to simplify inside that set of brackets first. So deal with the coefficients first. 50 can be divided by 2 to get 25. Okay, x squared on top, x to the power of 4 on the bottom. That gives us an x to the power -2. On the basis of y's, you are going to get a -3 as that exponent. And on the outside, still that power of 1/2. Okay, now we can apply that. But remember, that gets applied to the exponents, not the coefficient. So don't multiply it with the 25 to get 12.5. You can't do that. That exponent of 1/2 goes to the exponents only. So you are going to get 25 to the power of 1/2. X squared, or not x squared, I'm sorry, our base x with our -2 multiplied with 1/2. So if I take -2 and I multiply it with 1/2, we're going to get -1. -3 multiplied with 1/2, we get y to the power of -3/2. Okay, so I've dealt with everything. Now we got to make sure we turn those exponents to positives. So the 25 to the power of 1/2 will stay. The other 2 will move to that denominator. So x goes underneath, and y to the power of now +3/2 should be underneath. So we'll deal with those in our next couple lessons. But for now, this is a totally acceptable answer. Exponents are positive. Everything's simplified. Nothing else I can do. One more here before we wrap this up. Last one, letter H. And again, just remember, I will give you that fold-out solution key in the description box. So if we take a look, and I'll approach this the same way. Coefficients together, x's together, y's together. Coefficients together first. 12 divided by 3 will get us a 4. Now the fractions are a little bit not nice for the x's, so I've got a -5 whole number, not whole number, sorry, integer, and then I've got a 1/2 on the bottom. So in a different color here, I'm just going to do that little fraction operation. So -5 minus 1/2. So I want to make that 5 have a common denominator of 2, which will mean it's -10/2 minus 1/2. So 10/2 is the same thing as 5. So doing that subtraction gives us that -11/2. Now, if I just put it in my calculator instead, -5 minus 1, I'm going to put it in brackets, 1/2. Now, your calculator will always give you the decimal equivalent. So what you can do if you've got a graphing one is about third of the way down on the left side, there's a button that says math. You're going to want to press it. Option 1 has a little arrow and it says frac for fraction. So you can press 1 or enter. It will take your answer that's on your screen and it will change it into a lowest terms fraction if possible. So hit enter, -11/2, exactly like we did it. So as long as you know how to use this fancy expensive brick, this will be really nice for you. So there's your fraction, -11/2, and that's what we're going to use. So our x's, oops, wrong blue. Our x will have a power of -11/2, and then our y's. 5 over 2 on top, negative 1/2 on the bottom. We are subtracting. So if we have 5 over 2 minus negative 1/2, really we're adding, so we get 6 over 2 or 3. Okay, when I reduce that, sorry, there you go. So 5/2 minus a negative half. So I'm adding there instead. 6 over 2 reduces to 3. So whichever one you want to choose, 6 over 2 or the 3, makes no difference. We have to simplify it anyways. So the only thing left to do, make our exponents all positive. The only one that gives us the problem is that x. So the 4, the y cubed stay on top. Our x to the power of 11 over 2 now on the bottom. Fully simplified, positive exponents, all is good. So there you go. I will make sure that I get those other ones completed and posted for you. So when you come back to see the next video, whenever I happen to get around to that, we'll talk about those number sets and what constitutes a rational number from an irrational number, integers, whole numbers, natural numbers, all of that kind of stuff. So please check back a little bit later, and if this is helping you, like it, subscribe to the channel, all that kind of good stuff. And yeah, if you do have some questions, comment down below and I'll hopefully answer them. You can even email me as well, and I hope I should get around to that. So I hope everyone is doing all right, and we will see you next time whenever I figure out how to close this. I'll just keep talking until that's the case. All right, there we go. See you guys next time.